To get better at SQL, you need to practice, and one of the best ways to practice is with a project. This video will take you step by step through a project. In this video, you'll learn how to import a sample dataset, make some adjustments, and write some SQL queries to answer some questions we have about the data. For this project, we'll use a sample dataset available from the Our World in Data website. The dataset is called Population Growth, and it shows the data for countries and regions around the world. You can find this page at ourworldindata.org/population growth, or click the link in the description. The first step is to download the data. We can scroll down to the Explore Data on Population Growth section, which has a nice interactive visualization. At the bottom of this chart, there's a small button that says Download. This will let us download the raw data used for these charts in a CSV format. Click the Download button. On the pop-up, select Full CSV. You'll then be prompted to save this file to your computer. Select a location and then click Save. I'm doing this on a Mac, so if you're on Windows it will look a little different, but it will still work. The next step is to import this CSV file into your database. The exact steps for this will depend on which SQL editor you're using and which database you're using. In general, there should be an option in the editor to import data, and you can follow the steps to select the CSV and import it into a table. I'll import the data using dbeaver on a Postgres database, but you can use any SQL editor and database. I'll add some links to the description for the other videos I've made that show how to import CSV files into a database. This can be one of the hardest parts of this process, so if you have any questions or issues, leave a comment on this video. Let's get started. I'll start by creating a new schema for this data, so we can keep our data contained just for this analysis. In dbeaver, once you have connected, expand the databases, then Postgres, then schemas. If you don't have a database called Postgres or something you want to use, you can create one. Next, right-click on Schemas and select Create New Schema. For the name, we'll enter population, as we're using it to store our population data. Click OK. It should appear in the database navigator on the left. In this list of schemas, right-click on it and select Set as Default. This means it will be the default schema whenever we open a new SQL tab, which saves us time. The schema name will be bolded to indicate it is the default. Next, we need to import this data. To do this, right-click on the schema and select Import Data. This data transfer window will appear. It shows the steps we need to take on the left and the main section in the middle. The only option we have here is CSV, so click Next. A window will appear for you to select a file. Browse to the location where you saved that downloaded population CSV file and select it. The file name will appear in the source at the top. At the bottom of the screen, you'll see some options for importing the data. Most of the defaults should be okay. However, the one value I recommend changing is this sample rows count. It defaults to 100, but I would suggest changing it to 1000. This value is used by the import process to look at a number of rows and determine the most appropriate data type. With more rows to read, the import process can make a better assessment of the data type and size. Click Next. We will see the Tables Mapping step. This will create a new table called Population and Demography CSV. One important step and a common area for failure is the columns and data types. This is the case for many SQL editors and databases, not just dbeaver. We can view the columns that will be created by clicking on the Columns button on the right. We can see a list of all of the source columns, which are from the CSV file. We can also see the target column names and data types. In dbeaver, most of the columns have been set to int8, which is a large integer type and is enough for this file. This was automatically selected because I changed that sample rows count to 1000. When I left it as 100, it had a data type of int4 and the import process failed. So make sure your data types here are large enough. I believe the largest value in a column is around 8 billion, so choose a large enough integer for your database. Also, ensure the country name field is large enough. I used a value of 200 and it was okay. Once you are done, click OK on this column screen and then click Next. You'll see the Data Load Settings screen. You can leave the defaults and click Next. You'll then see the Confirm screen. Click the Proceed button. The data import will start and should finish in a few seconds. There are about 18,000 rows. Our data is now imported. If you have any issues importing the data, check out the videos I've linked in the description or leave a comment below. Now our data is imported, let's see what's in the table. Click on the X on this tab to close the tab about the table. We'll open a new SQL editor window, and we can do that in dbeaver by selecting this drop-down and clicking New SQL Script. A new SQL editor tab is opened. We should also see at the top of the screen that the schema and database are selected, which is population at Postgres. If this is not the case, you can click on the drop-down here and change it. Let's run a query. We'll select all records from our new table. We can run the query and see our results here. We've got a column for the country name, the year, the population, and a lot of other population columns, which are broken down by age groups. It looks like we have one row for each country and each year. What range of years does this table include? We can run another query that finds the min and max of this year column. We can run this query, but we get an error. It says the column year does not exist. It could be because the column name is in uppercase, but we have lowercase. Let's change it to uppercase and try again. We run the query, but it fails again. Why is that? Let's go back to our query that showed all columns. We can see the data in columns here. We see the year column, but it starts with a capital letter. We see the country name column, which starts with a capital letter and has a space. Several other columns include spaces and others include underscores. This has happened because the import process has used the heading from the CSV file, which included the heading as it was written. The problem with spaces and capital letters in the column names is that we get errors like this, and they are hard to work with. We can select these column names by enclosing the name in quotes and specifying it exactly as it is stored. We can surround the year value in single quotes, change it to a capital Y, and run it. We see the results, but both columns say the word year. That's because a single quote in SQL is used for literal string values, so we have just selected the word year. Let's change them to double quotes. We can run this and see a different result. This is better. We see the min year is 1950 and the max year is 2021, so our population data is from 1950 to 2021. Good to know. Now we could start doing our data analysis and writing queries, but enclosing our columns in quotes like this every time is going to be a hassle. It would also be harder for any other tools that connect to this data. The way to fix this is to use an alter table statement. We'll run some alter table statements to rename the columns to names that are much easier to work with. We start with alter table, then our table name. I've got this alter table command in a script in my GitHub repository, which is linked in the description, so you can copy it from there if you don't want to type it. We write rename column, then the column country name inside quotes, as that's how we need to refer to this column and that's how it was imported. Then we say to, then we give it an easier name of country name. This command works on Postgres, and if you're on a different database, your command may be slightly different. Run this statement and the column is renamed. We can see this has been updated by going to the navigator on the left, expanding our table and then columns, and then right-clicking on the table and selecting Refresh. We can see our renamed column here. We can do the same to the year column. We'll rename this to population_year because the word year is used by a function. Run this command and the column is updated. In this table, we've got a range of other columns that include spaces. We should also rename those. Once again, I've got a link in the description to the script that has all of these statements, so you don't need to type them out. We can select these statements and run them, and the column names are updated. Right-click on the table on the navigator and select Refresh, and we can see the new names. That should make our queries much easier. Let's have a look at the different countries we have. We can select the country name and the number of records for each country, using this select query with count and a group by and order by. We can run this query and see our results. It looks like a list of countries, and all of them have 72 rows. If we keep scrolling down, we can see some values that don't represent countries. There's a value here of Latin America and the Caribbean, UN, which seems to represent a geographic region. There's also a value of less developed regions, which may indicate a group of countries or regions. So not everything is a country. We see a few more of these types of records. There's a record here for North America. It also has a UN in brackets. What other rows have a UN like this? Let's write a select query that does a partial match on this. We can run this and see our results. There are 6 rows and they represent geographic regions or continents. To make our analysis easier, it would be helpful to have a column in this table to indicate the type of record each row represents. Some records are countries, some are continents like this, and some are other types that we saw earlier. Let's add a new column for this. We can do this using Alter Table, and we'll add a new column called Record Type. This will be a simple text value. If we were going to normalize this table, we would have a separate lookup table with a primary key and a foreign key, but for our purposes we can keep it all in the one table. We can run this statement and the table is updated. Let's set this record type column for these continent values. We can do this using an update statement. We'll set it to continent for rows that contain the UN value. We can run this and see it is successful. Now let's see what else is in this table that is not a continent. We can select the distinct country name values that have a null record type, meaning they have not been updated yet. In the results, we can see there are mostly countries. There are some other records like high income countries that we can see. Let's say we've gone through this list and found all of the values that are not countries, and we want to update the record type to be a value of category. Here is the update statement we can use. I'm not sure what countries are included in each of these, but for us it doesn't matter. We just want to separate these records from the actual countries. So run this statement and the table will be updated. The remaining records in this table are all real countries, so let's update the record type to country where the record type is null. We can run this and the data is updated. Let's see the data in our table now. We can see our updated column names here, all lowercase and underscores without spaces. We can see our new column on the far right here as well. Our data is now ready for us to work with. Let's say the first thing we want to know is about people aged 90 and above. So what is the population of people aged 90 and above in each country in the latest year? How can we find this information? Let's look at the column list. We have a column that shows the population from 90 to 99. We also have a column that shows the population for 100 and above. Let's look at this data. We can look at the country name, the year, and these 2 columns in our table. The results are here. We can see multiple rows for each country. This is because there is 1 row for each year. We only want to see data for the latest year, which we found earlier was 2021. So let's add a where clause for that. Now we only see 1 row in each country. We see different values for each country, which is interesting. But in our country list, we see some of those continents, the values that have a UN inside them. We only want to see countries for this query. This is where that new record type field comes in. We can add another filter on record type equals country and run the query. This looks better. Let's order it by country name. We can see our results in order. We wanted to see the population for 90 and above. Currently we have this in 2 columns. Let's combine them into a single column by adding the 2 numbers together. Let's run this query. We can see that our results show a single column for the population of 90 and above. This answers our question. We can see the population of each country of people aged 90 and above. If you want to get all of the SQL queries mentioned in this video, including the select queries, and all of the data updates, get your free guide to this project by checking out the link in the description. Let's move on to the second question. We want to know which countries have the highest population growth over the last year. We want to see the number of people as well as the percentage increase. Let's look at our data again and filter to only show countries. As we know, we have a list of countries and different rows for each year. We want to see a list of countries and the change in population in the last year, so population from 2020 to 2021. Now the tricky part here is that this data is in different rows. We can compare data in two different columns pretty easily, like we did in the last lesson, but to get data from two different rows and compare it is a bit harder. There are a few ways we can do this. One way is to use a function called lag, which will allow us to look at a value in a previous record. Another way is to use a subquery inside the select clause. Let's try that way. First, we want to select the country name. We select from our table and filter on the record type of country. After the country name, we want to show another column. We want to see the population value, but only for the year 2020. We can do this with a subquery. So we add a comma, then open the brackets. Inside the brackets, we write a select query. We say select population from our table. Then we add a where clause. We want to match this data in the subquery to the data in the main query. We do this by matching on the country name. And to do this, we need to give each table an alias. We'll give the main query an alias of P, and the subquery an alias of P1. We'll add this to each of our columns as well. In the subquery, we add a where clause and match on the country name in both tables. Now, this column we're showing with the subquery needs to show the population for the year of 2020. We can enforce that by adding the year of 2020 to the where clause. Let's run this query and see what happens. We can see a country name and a population number. We see multiple rows for each country, so it's not quite right. Let's validate this data. For this country here, Afghanistan, we see a value of about 38 million. We can run the earlier query to see if Afghanistan really has a population of 38 million in 2020. We can see that yes, it does. So it looks like our query has gotten the 2020 population, but it's showing multiple times. Why is that? Let's add some more fields to our query. We can add the population year to see if that changes. When we run this, we can see that there are multiple rows for each country because each year is different. We want to see only one row for each country. We can do this by adding a where clause to the main query to filter on the year of 2021. It doesn't actually matter which year we filter on, but we need to filter so we only see one row for each country. We can run this and see only one row for each country. That's better. Let's remove that year from the select clause and keep going. What's next? We want to see the population change in the last year, and we have the 2020 population. Now we need the 2021 population. We need this in another column. We can get this easily by copying the existing subquery and pasting it as a new column. We can change the year in the second subquery to 2021. Let's run the query. We can see the results and there are two population values here. Great, we're making progress. How do we know which is which? Both headings say population. Let's give them a column alias to make things easier. This is better. We can clearly see which number is which. Now we need to see two more pieces of information. The difference in these two numbers and the percentage change. We used a subquery to determine this number, and if we want a new column to show the difference, we'll need to use a subquery again. However, there's a better way to do this. We can treat this entire query as a subquery and select columns from it to do further calculations. This is easier than copying and pasting columns. Let's do that now. First, we select the columns we have at the start of the query. We add from and then an open bracket. Add a closing bracket at the end of the query, then an alias which can be something simple like S and then the semicolon. Let's run it and see the results. We see the same results as earlier. This is good. Now we can add more columns. Let's add a column to show the difference between the two. We'll get the 2021 population and subtract the 2020 population, and call the column pop growth num. We can run this query and see our results. We see the change in the population value. We didn't need to run another subquery as we already have the columns we need. Let's work out the percentage change in population. The formula to do that is the 2021 population minus the 2020 population, then divide this by the 2020 population. We then multiply this by 100 to get a percentage value. Let's run this and see our results. We can see the new column here. However, all of the values are 0. If you're running this on another database, you may get some small decimal values, and that would be the expected value. However, on Postgres, this shows as 0. The reason is that both of the population values are integers, and when we divide integers, small numbers will tend to be rounded down to 0 instead of a decimal. How can we fix this? We can convert one of the values in our expression to a decimal by using the cast function. It doesn't matter which one. Let's try that. We'll cast the result of this subtraction to a decimal. This should be enough for Postgres to show us decimal values and not a 0. Let's run it. Alright, we can see some decimal values in the new column. We can see our first row, Afghanistan, has a change of about 2.8%, which is the value of 1.1 million as a percentage of 38 million. This is what we wanted. We see many decimal places here, so let's surround this with a round function and round it to 2 places to make it neater. We run this and see the numbers are rounded. Finally, let's order the results by the number of population change from highest to lowest. Run this and see the results have changed. We can see a list of countries sorted by the number that the population has increased. This is what we wanted. We can scroll to the bottom and see there are actually some countries who have declined in population, which is interesting. So that's question 2 answered. There was a bit of work in this, but we got to the result we wanted in the end. Let's say the next question is which single country has the highest population decline in the last year. This is kind of similar to the last question. We want to see the population changes for countries in the last year, but only see one country and see the country with the biggest decline. So we can copy the query from the previous question. First, let's see if countries, but sorted by their population decline. We can do this by changing the order by to ASC. At the top of our list is Japan. It has a decline of about 632,000. For our question, we want to know the single country. So let's assume we don't want to show any of the other countries. To do this in SQL, we use a feature called row limiting. In most SQL vendors, we can use the limit keyword for this. We can add limit 1 to the end of the query, after the order by, to only show one row. We run this and see a single row. So question 3 is now answered. Let's say we want to know which age group had the highest population worldwide last year. We'll start by looking at our data. In our results, we can see a range of countries and different categories. I remember there was a value of world, which I assume represents the worldwide population. Let's filter on that. This looks good. We can see the population was about 2.5 billion in 1950 and about 7.9 billion in 2021. Our question was about the highest population in the last year, so we can filter our results to only show the row for 2021. We can see one row in our results. We can see each of the population values by age group as we scroll to the right. How can we work out which age group has the highest? We could use a max function and provide all of the columns to this function, but that would only give us the highest value and not the age group that the value relates to. There is another way. We can translate the data from showing the age groups in columns to showing the age groups in rows. This is called pivot or unpivot, depending on the direction you go. We want to have a column that shows the different age groups and another column with the population value. We can then sort by this population value to see the highest group. What columns do we need? We can look at our available columns here. Let's assume that we want to show the age groups by decades, so 60 to 69 and 70 to 79 and so on. We have columns for each of these, except for 1 to 9, which are split into 2 columns. We can combine these. So how do we do this in Postgres? We use a technique called unpivot. The approach is different in each vendor, but here's how we do it in Postgres. We start with select. For our first column, we use a function called unnest. This will allow us to convert columns into rows. Inside the unnest function, we specify the word array. Then we have square brackets. Inside these square brackets, we specify a list of values for each of the rows we want to see. We use values inside single quotes and separated by commas. For this example, I'll use names similar to the column names, but you can call them what you like. Notice that the first entry is for the range of 1 to 9. We'll see in a moment how to calculate this. After the sets of brackets, we add a column alias. We'll call it age group as it describes what this data is. Next, we need to define how the population is calculated for each of those rows. We write another unnest function, then an array. Inside the square brackets of the array, we add in each of the database columns we want to use. We then separate them with commas. Also, for the first column, we add both the 1 to 4 column and the 5 to 9 column to get our 1 to 9 value. We can do the same for the 10 to 19 value. We'll call our column population. Our query should look like this. Finally, we'll add an order by to see the data ordered by population. We can run this query and see our results here. It shows one row for each age group we defined, and then the total population for that age group. We can see the group with the highest population is 10 to 19. That answers our question. Let's move on to question 5. What are the top 10 countries with the highest population growth in the last 10 years? This is based on the number and not on the percentage. This seems similar to the earlier question about growth in the last year. However, it's over the last 10 years and we only want to see 10 rows. So let's copy the earlier query and paste it here. We can change this query to look up the population in 2011, which was 10 years before 2021. We also need to change the outer query to show the 2011 value and not 2020, and then the calculations. We can remove the percentage calculation as well. Run this query and we can see countries and their population growth in 10 years. Finally, we can limit this to only the top 10 rows by adding limit 10 to the end of the query. We can see the top 10 results here ordered by the population growth in 10 years. So that's how we can answer this question. Let's say the next question we want answered is, which country has the highest percentage growth since the first year recorded? We could copy the previous query again. However, you're probably noticing a pattern. Many of our questions are based on comparing populations across different years. We can simplify this query and our other queries by creating a view that calculates the population in each year for each country. We can then select from this view to make our queries easier. To do this, we copy our previous query and add Create View in front of it. We'll call the view Population by Year. We'll remove the order by as we can order our results in our queries and not in the view. And we can remove the population change columns as well. Now, to make our view useful to the other queries, we can add in separate columns for each year. We'll need a column for 1950, which is the first year, a column for 2011, a column for 2020, and a column for 2021. Update the query to have these columns in the subquery and then in the outer query. Run this command and the view is created. Now let's select from this view. For this question, we only need to see the population change between 1950 and 2021, so we select those columns. Run this query and we can see the results that show the two populations. Now we need to calculate the percentage difference. We had this in an earlier query and it used the round and cast function. Let's copy it here. We can rename the columns to refer to 2021 and 1950. Finally, we'll order by this new column in descending order. Let's run this query. We can see the results here, and it shows the countries with the highest percentage growth are the United Arab Emirates, Qatar, and Western Sahara. We could update our earlier queries to use this new view if we wanted. Let's move on to the next question. Let's say our next question is about those aged 1. Which country has the highest population at age 1 as a percentage of their overall population? We'll start by selecting a country name and population. We only want to see countries and the latest year of 2021. What's next? There's a population called Population at 1 that shows the population of 1-year-olds. Let's add that to our query. Let's run the query. We see the population at 1, but we want to see this as a ratio or percentage of the overall population. To do this, we can use the same round and cast functions we saw earlier. So we'll copy the code from a previous query and paste it here, updating the column names to use the two that we have. We don't need to subtract two columns. We just need to divide one by the other. Now we can rename the alias to just call it pop ratio instead of growth. Now let's sort by this new column. We run this query and we can see the countries that have the highest population of 1-year-olds compared to the total population. That's question 7 answered. If you found this useful, then you'll love my guide to this data analysis project, which includes all of the SQL used in this video. You can get your copy using the link in the description. Our final question is about continents. What is the population of each continent in each year, and how much has it changed in each year? After we answer this question, I'll show you what to do next with this file you've created. Let's see how we can answer this question. We'll start by selecting the country name field and the population. We are looking for data on continents, and we have labelled those with a record type of continent. So let's add a where clause for that. We run this query and see some results. We can scroll through and see how the population has changed for these continents. However, we want to show the actual change in population in each year. How do we do this? We want to show a column that shows the difference between each record's population and the previous year's population. We can use a function called lag. I mentioned this briefly earlier in the video, and it's a pretty useful function. It allows us to look up a value in an earlier row and use it in the current row. We start by writing lag. Inside the brackets, we specify the column we want to look up. In this example, it's the population column. After that, inside the brackets, we specify how many rows back that we want to look. We want to see the previous year, so we specify 1, which is 1 row back or 1 row earlier. Then we need to use this as a window function, so we add the keyword over. Inside these brackets, we need to specify how the data is ordered to calculate what 1 row back means. For us, it means the row in the previous year, so we say order by population year ASC. We'll give this an alias of population change. Let's run the query. We can see some data in this new column, but the records are not in any order. Let's change that. We'll order our results by the country name and then by year. Our results look a little better, but the new column is still all over the place. I was expecting some consistent numbers in the change in population, but they seem incorrect. Why is that? Well, it's because the lag function is looking at the record for the previous year, but it's a previous year for any continent. We are viewing the data by continent, but we haven't told the lag function that we want to see the previous population for this continent. We can do that by using the partition by clause inside the over keyword. Let's add that now. We can run this again and see our results. This is much better. We can see the population change on the previous year here. As we scroll down, we can see the increase in Africa keeps increasing. When we get to Europe, the number resets and the increase is much smaller. This is what we wanted to see. Our final question is answered. Once you've written some SQL queries to analyse some data like this, hopefully you'll be a little more confident. If you want to show these skills and your capability to others, such as recruiters or teammates, the best way to do this is to add the SQL script to a GitHub repository. Watch this video next to learn how to create a GitHub repository and add your SQL files. Let me know in the comments below what you thought of this SQL project and if you'd like to see more of these. Thanks for watching.